This is the guts of one of those contract systems associates multitester thingamajigs. Inside, it's all pretty much a circuit board with 7 neon lamps and a pair of LEDs on it. The neon lamps function both the top two. The top one on either side is the are for polarity on DC for 90 volts or more. Then the bottom three on the left are potential indication. The 440 volt, 500 volt one most likely being a somewhat different gas formulation, or a different type of neon lamp because there's a little red blob of paint on it to indicate that it's different, most likely different operating potential or something, because it is a 440 volt, 500 volt lamp. And then these two are frequency indication. Then the rest of it are a bunch of carbon composition 5% resistors. This was made in 1982, so that's to be expected. Nowadays pretty much it's all metal film or carbon film. And there's some capacitors, a pair of 1N4763A 91 volt avalanche diodes wired in series with reversed polarity, which is expected for AC potential limiting applications, so that is normal to see. And there's one mystery component, which is, I'm guessing, some kind of positive temperature coefficient device. That's this little blob of gray metal. That is for that is wired in series with both LEDs and this 3900 ohm wire wound resistor. Don't know how good it's going to show up on camera, but this is the schematic of the device. It's pretty much 3 separate components. There's the frequency testing portion of it, which is this bit right here, which is pretty much as suspected in the review video. Yeah, it's just a little piece of plastic film held in place with masking tape. Ordinarily, there's this little plastic spacer that all the lamps slot into that provides actual mechanical support for the frame, but then again, this isn't really designed for roughhousing anyway. It's pretty much just a couple of filters that, in the case of the 60 cycle per second lamp, all the neon indicators for the frequency, by the way, are wired in series with the whole apparatus is wired in series with a 39,000 ohm resistor and a 100 nanofarad capacitor. There's after all that, there's a 150,000 ohm resistor and the 60 cycle per second neon with a 6.8 nanofarad cap to short that out at higher frequencies so that would not illuminate above a few hundred cycles per second, so that only the 400 cycle per second one would light. And conversely, there is a 1 nanofarad cap wired in series with the 400 cycle per second neon, and then another resistor tying that junction over to a potential divider that's a 470,000 ohm resistor, connecting it to the center of a potential divider consisting of a 2 million ohm resistor and a 330,000 ohm resistor. The idea with that is that pulls down the potential of the neon lamp, of the 400 cycle per second neon lamp, at somewhat lower frequencies, and when it gets up to above, I guess, 300 cycles per second, I haven't had a chance to test this, the potential across that lamp is sufficient for it to fire. That resistor, of course, being so that it doesn't short out the potential divider. And of course, wired across all that are the 1M4763A anti-parallel potential limiter. No, not an anti-parallel, anti-series, I guess. Then for the polarity indication, there is a 470,000 ohm resistor. Then there is a 100 nanofarad capacitor wired across the neon assembly with a pair of neon lamps and a pair of 1N4007 rectifiers. The idea is that the rectifiers keep only one lamp lighting, so that only one lamp lights at a time, depending on the polarity, and the 100 nanofarad capacitor shorts out that at on AC so that neither lamp illuminates, which is somewhat weird, but this is most likely intended for somewhat non-skilled users with absolutely no electronics experience, so that only red negative or black negative or 60 cycles per second or 400 cycles per second light, because otherwise the thing like, oh, that might be some kind of a new, is it like the DC with like the both play, which you can sometimes see in those who have absolutely no electronics experience. And then there's the potential section, which is the neon portion of it is fairly typical. It's pretty much exactly the same design that you'd find with in one of those little cheapy neon potential testers, except this one for the some of the higher resistances, which would be carrying which would have somewhat higher power dissipation, they've actually got higher power rating resistors. Like that is, I think, a 2 watt for the 39,000 ohm resistor there, and and the 27,000 ohm resistor right next to it is a half watt. Ordinarily, in a Chinese piece of crap, those would all be quarter watt resistors, and consequently the thing could burn out after a time. So that is a fairly typical design, just a potential divider with neon lamps wired across some of the resistors. That is fairly standard design. Except one interesting thing about it is that it is wired with a on the output of a Gray's bridge rectifier. Again, comprised of 1 in 4007 rectifiers right there. And there is also a 220 nanofarad capacitor wired across the neon potential divider. Most likely for ripple suppression, so that this thing reads about the same on AC or DC, since it is designed for use on either type of electricity. Most of the crappy ones that you find nowadays are designed for AC only use. They're designed to be reasonably accurate-ish on AC, because with AC, again, because the peak potential is about 41.4% higher than RMS, and the RMS potential, what happens is that it could cause, on AC, it would cause some of the thing to read high, or on DC, it would read somewhat low. So that is most likely, or vice versa, busy. But, so that is most likely for maintaining a degree of accuracy on either thing, just as a little ripple suppression. And then there's the LEDs, which is a pair of them, wired in series with a 3,900 ohm resistor, and that mystery, what I'm guessing is a positive temperature coefficient device of some sort, that limits the LED current to about 20 milliamperes or so, which is also why they warn you not to use in the supplied literature, which is just a printed piece of paper, that this is not to be meant hooked up in the circuit for long periods of time, because that would, on 500 volts at 20 milliamperes, that thing would be dissipating almost 10 watts, which is most likely why they have the supplemental wire around resistor. Of course, it is just a little block or some kind of a metal alloy with leads soldered onto the ends. But that's pretty much it. It's somewhat interesting in design. It's got things that you don't see a lot in modern crap. But then again, it was domestically made. It was domestically made 30 years ago, so it expected to be of some degree of quality. Oh, and also this is not the one that I did the original review on. That's this one. It's just that the Hamfist, because they're a useful gadget. So another one, and grab it. Actually, from the same guy I got the other one on, and I got a whole bunch of other miscellaneous goodies like terminal blocks, LEDs, temperature indicating stickers, you know, good stuff. But Hamfisting, you find stuff like that. So that's pretty much what's inside one of these.